Okay, so it is a rainy Saturday that I'm doing this video on. Mr. Earth is trying to keep everything very green. So he's raining. So it stays green. It's raining all day long. So we're going a little crazy. So tonight's video is on systems of equations. Make sure to put your date on your paper. All right, so systems of equations is when you look to see if two graphs have a point in common or more than one point. So as this says, systems of equations show how many points the two lines share in common. Now it could be two other things. It could be a quadratic and an exponential, and the point that they share, if they cross over. You know, if you had like a quadratic like this and like an exponential going like this, that would be a point that they shared. Or if you had a quadratic equation and then a linear equation going through it, then that would be the points that they had in common, would be their intersection. So it doesn't necessarily have to be linear, but it's the points that two functions share. So we're going to start off fairly easy with slope-intercept form equations. We're going to graph these two. So if we, look here, for this one, the slope here is 1, and the y-intercept is 2. So we start at 2, and we go up 1 over 1, up 1 over 1. And then for this equation up here, the y-intercept was 5, and the slope was -2. So we start at the 5 here, and we go down 2 over 1. And you can see these both share 1 point in common. So this is called one solution because it shares 1 point, and it's called a consistent system, which means one solution. Okay, and then if I want to check and see if this 1, 3 is correct, I can plug it in my equation. So I plug in the 1 in for x and the 3 in for y, and you can see 3 equals 3. And then in this equation, I plug the 1 in for the x and the 3 in for the y, and 3 equals 3, so we know it works for both. Okay, so let's look at this equation. So if we look at this equation first, that's in standard form. We've got to put it into slope-intercept form. So we're going to subtract our 2x over. And don't forget that this is -3y left. And that's -2x minus 2. And then we divide by the -3. Okay, so when we finish that, we're left with y equals negative, so that's positive 2/3 x. And then that's positive 2/3 for the y-intercept. And we're going to do the same thing here, minus 4x. So that gives me y equals -4x plus 24. So then we're going to do some graphing over here. So it looks like this. And then you can see again, it has 1 point in common, so it's one solution, and it's called consistent. And then if we plug in our x and our y, it works out just fine. All right, so the next one we're going to look at is this one. Okay, so here we can see this is in slope-intercept. This has a slope of 1, and this has a slope of 1. So that should tell you something. So when I graph it, I have a y-intercept of -3 here, and it goes up 1 over 1. So that line's going to go through there. And then this has a y-intercept of 2, and it goes up 1 over 1 each time for the slope of 1. So you can see they're parallel lines. So because they're parallel lines, these won't ever cross over each other. So this has no solution. It's called an inconsistent systems because it shares no points ever. So we make a little note about parallel lines. So we know if it has the same slope, we can stop because we know it's no solution. There's no points it'll have in common. All right. So then let's look at this one right here. This one again we want to put in slope-intercept form, so we'll subtract our x, and I'll get negative y equals negative x plus 2. Don't forget that's negative y. And then we can divide through by negative 1 because we can't leave y negative, right? So that will give me y equals x plus, that's negative 1 right here, so plus negative 2, yeah? So we're at negative 2, and it's going to rise 1 and run 1, so that'll be my graph. So now we got to get this one in slope-intercept form, so we'll add the 2x over, and I get 2y equals 2x minus 4, and then we divide by 2. And then we have y equals x minus 2. Y-intercept of 2, rise 1, run 1. Oh, you should find that those are at the exact same line. So what do you think the solutions are going to be? How many points do they share if it's the same line? You got it. It's all real numbers. Or you could say infinite solutions. And this is called a dependent system. One depends on the other because they're the same. Okay? So we're going to end with a little quiz. You have to name each one of these systems here. We'll call this one 1, 2, and 3. Good night.